Hey everyone, welcome back to our channel. Today we are focusing on our last tutorial on OOP part 4. It's about polymorphism, which is a powerful concept in object-oriented programming. If you are ready, let's get started with theoretical concept then the practical examples. So, what's polymorphism? Polymorphism is a powerful concept in object-oriented programming that lets us treat different classes through a unified interface. It's all about designing flexible systems where code can work seamlessly with objects of different types as long as they follow the same behavioral contract. This is achieved through tools like abstract base classes or ABCs, which ensure that all subclasses implement specific methods. We can also use abstract methods and protocols to define those expected behaviors. And then comes method overriding, which allows subclasses to provide their own unique versions of these methods, creating class specific behavior while still fitting into a shared structure. Let's learn about all of this. Let's continue with method overriding. We have already seen it, but in this tutorial, we will try to create another class and see it more effective. There will be three different attack functions, one for base class, one for mage, and one for warrior. So we will convert our warrior character to the object of another class. So we will create a class named warrior with armor to add it an extra damage. Let's define class warrior character and init self name health strength. This time not mana like mage, but this time it's armor. So we will also call super dot init to send common parameters health and strength. And again, since armor is different, self.armor equals armor, I say. After that, we can define an attack function and say self target and call attack function like this. So in the attack function, it says take damage with an amount of self.strength. We can temporarily add armor to strength before attacking and then again subtract it without modifying attack. Another way is modifying the base attack function to get damage as parameter, but we don't need that now. So let's say self.strength plus equals self.armor and super dot attack target. After that, we can again subtract armor. So what actually it does, if our character wears another armor, it won't get affected by these changes. So it's more ideal. Now let's try this function and run it. So our hero is no longer created from the character, but it should be instantiated from warrior. And we should also define armor, let's say 10, and remove this and print hero dot attack enemy. It should inflict 25 damage and print enemy dot display info. But if you copy this return statement to say here, it will return the amount of damage it inflicted. So if you run this, you can see warrior inflicted 25 damage on skeleton and skeleton's health is -5. We can prevent health from going below 0, but we don't care about it yet. We can do it using max function and we will see it. Now let's talk about abstract base classes, ABCs, and their abstract methods. Ensure every RPG character has consistent battle methods like attack for polymorphism. So what ABC provides to us is it enforces you to implement some functions if you inherit from this class, so your subclass becomes consistent. Let's define an abstract character class. You should first import ABC. From ABC, import ABC and abstract method for abstract methods. Define class like this, class character, same until now, but inside parentheses ABC in uppercase. And let's define its constructor, self, name, health, and strength. Self.name equals name, self.health equals health, self.strength equals strength. After that, let's define an abstract method. Let's define an abstract method and define attack self target. Say pass. Pass helps you to define a function without returning anything. So since it's abstract, you can define useful functions in abstract classes, but if you mark it as an abstract method, you should implement it only in subclasses and not the base class itself. So base class only acts as a prototype and define take damage self, comma, amount. Let's also define health private, but this time as a convention, not a strict one. Self dot health. If you want to make it strict, use double underscore minus equals amount. Return f self dot name takes amount damage and define get health self return max 0 self dot health. So its minimum value is 0 now and it's plausible. We won't get anything negative. So def display info self return f self dot name hp self dot health str self dot strength. Here we make character and ABC using the ABC model and mark attack as an abstract method. Subclasses must implement attack, ensuring a consistent interface for battles. Let's revise our Mage class according to this. So define class Mage, inherits from character, define init function, self, name, health, strength, and mana. Super dot unit name, health, strength, self dot mana equals mana. And define attack function, define attack self target if self dot mana greater than or equal to 10 self dot mana minus equals 10 damage equals self dot strength plus 5. Let's add some extra damage. Return target dot take damage else this if block won't execute, so you can return target dot take damage self dot strength. So let's instantiate some objects. Mage equals mage named mage, can find another name for it, so, and 120, 15, and 100. So it's health, strength, and mana respectively, the numbers, and the first one is name. Enemy equals character. Let's instantiate it from the character class. Say skeleton 50, 10, print mage dot attack enemy. And why it raised error? Because you cannot instantiate abstract class character with abstract method attack. Since it includes an abstract method, you have to implement it. So you cannot do that. Let's create enemy mage and instantiate it from Mage class again, say bad mage, and define a mana point for it, and mage.attack enemy mage. And if you run this again, it says bad mage takes 20 damage. So we have successfully implemented it. If you don't implement using an abstract class, it will raise an error like this. I have done this to show you because it's an important concept about polymorphism. Let's also cover protocols. You can use protocols to enable flexible type-safe polymorphism, letting any object with the right methods join our RPG battles, no inheritance needed. You don't need to inherit to use these classes. Let's see an example. From typing, import protocol and define a class named combatant and inherits from protocol. Define attack self target colon after that ellipsis and define take damage self amount. Define get health self class dragon. Will be something like this. Define init self name health strength. Self dot name equals name. Self dot health equals health. Self dot strength equals strength. Define attack self target damage equals self dot strength multiplied by 2 and return target dot take damage and define take damage function take damage self amount self dot health minus equals amount return f self dot name takes amount damage and for def get health self return maximum of 0 and self dot health here, so you won't get negative values again. And let's copy this class completely and define it as warrior. Let's call it warrior. Now we are done. All we gotta do is try their attack functions. The combatant protocol defines attack, take damage, and get health. Any class with these methods, like warrior or mage, matches the protocol. So attack here is our battle function. Say dragon equals dragon, called dragon again, with 200 health and 15 strength. And let's define warrior equals warrior with name warrior, health 100 and strength 10. If you print warrior dot attack dragon, it says dragon takes 20 damage. Dragon isn't a character but has the right methods, so it works in the battle. Protocols formalize this flexibility, ensuring type-safe calls for our RPG game. The code would still work without the combatant protocol because Python's duck typing allows warrior.attackDragon to function as long as Dragon has a take damage method, regardless of the protocol. The combatant protocol primarily adds type hints for static type checking, in example MyPy, but doesn't affect runtime behavior. So Python uses duck typing. If the object has the required method, the method call works. So the protocol is a powerful but only a typing tool, specifying that attack, take damage, and get health are expected for type checkers. Let's try to remove protocol and run it. As you can see, it still says dragon takes 20 damage. so it still works. Well, you have learned a lot in our Python OP adventure building RPG worlds with our warrior and his allies. You started with classes, creating the character class to give warrior a name and health. Then you used encapsulation to protect health with methods like take damage, keeping it safe and never below zero. With inheritance, you made mage and warrior classes to add special attacks. Finally, polymorphism let warrior and dragons fight in unique ways using the same code. If you want to support us, like the video and subscribe to our channel in order to catch the next tutorial. Thank you for watching.